Hello everyone. In this we will see our next problem, which is two sum 2. So we already have seen two sum, but this is different. So where we get in input array, we get input array is sorted. So let's go to the three methods. Given a one indexed array of integers nums. So one indexed means the index will start from one. We have to consider that way. So that is called in one indexed array of numbers that is sorted in non-decreasing order. So the numbers are in non-decreasing order, as you can see here. Find the two numbers such that they end up so that they add up to a specific target number. So we have to select a two numbers, we have to find out a two numbers in such a way that the excuse me, addition of those two numbers will be equal to our target. Let these two numbers be numbers index I, index 1, and numbers index 2, where index 1 and index 2 are between greater than or equal to 1, and also less than or equal to nums length. So index will not start from 0, but it start from 1. So we should consider one indexed array. Return the indices of the two numbers, which is index 1 and index 2, added by 1 as an integer array. So after finding out the indexes, we have to add 1, because these are one indexed array. So these test cases are generated in such a way that there is exactly one solution. So the test cases will be having only one like there is only one solution. For example, here we have target 9. So 2 7 is correct. 27 addition of 27 is 9. And also if we will get 9, 4 plus 9, 4 plus 5 also. But it is mentioned that there will be exactly one solution, which means in input it they will not give us in such a way that we will get two solutions. You may not use the same element twice, so you should not use the same element as twice. uh, for example, like if there is a 2, one more 2 here, then 7 plus that 2 also becomes 9. So in that case our answer would change. So that is what here it is saying. And your solution must use only the constant extra space. So this is one of the condition for because input array is in sorted order. So into some what we have seen is there we have used one um set, and using that set we have found out our indexes in order of n time. Each we have iterated through each numbers, and we have subtracted here 9 minus 2, which is 7, and in the remaining in set we have searched for 7. Initially 7 will set will be 0, there will be nothing in set. So we added 2 and its index as value. And then next we have 9 minus 7 becomes 2, and we check if 2 is present in set. So it will be present. So that's how we have returned 0 and 1. But in this case here it is specially mentioned not to use extra space, and the given array, and in the previous one to some the array is not in sorted order, but here it is in sorted order. So for example, in our example 1, this is the numbers and target is 9. So here 2 plus 7 is 9. So that is the reason we are returning we are not returning 0 and 1. Index of 2 and 7 are 0 and 1, but we are not returning 0 and 1. We will be adding 1 to each, and we will be returning 1 2. Same way here, numbers we get this, and target is 6. 2 plus 4 is 6. So 0 indexes are 0 and 1, 2, 0 and 2. So we will add 1 to each index, and 1, which becomes 1 3. And here also same, the target is -1, 1 plus 0 is -1, 0 and 1, but we will add 1, so 1 to each index, 1 and 2 is our answer. So these are the constraints we have. So numbers are in non-decreasing order, and this is such a way that exactly there will be only one solution. So the first method is so since the given array is in sorted order, we can easily make a binary search. So the first method, that is what we are going to do. So in first we get the numbers and target, and we iterate through our numbers. So let me just annotate it, and yeah, so we got numbers here. So and what we do is each time we we subtract that number from target. So here we subtract first index value, which is 2 from 9, so which becomes 7. So we search 7 in the remaining numbers of this list. So in remaining, we can search that by log n time, because these are in sorted order, so we can apply binary search for the remaining element. That is what we are going to do here. So here we will be calling the binary search, and for binary search we pass numbers and the index I plus 1, because I is already covered, and we have to search from I plus 1. I plus 1 to len numbers len -1, which is here 4, because the size is 4. So we have to search till 3, index 3. So that is what we are passing, and num2, which is our like the what number we have to search, which is 7, we have to search. So in binary search, this is a famous like algorithm, I guess you know. So what it will do is search half half. It makes given array half, and it will search half. So that's how it will take log n time. For example, here it will do is here we got indexes as 1 and 3, so it will do here 1 plus 3, 1 plus 3, 1 plus 3 becomes 4. 4 by 2 is 2, so it will check 2, index 2, nums of 2 is equal to target, which is not, 7 is not. Then and it will check if target is less than. So here don't confuse this target with this target. Here we got target as 9, but here this target is 7. So here we check if target is equal to nums mid, no. So we go here, we check if target is less than nums mid. This is yes, because 7 is less than 11. So we again search for only this half. So if it was greater than the mid element, then we would have searched the right side half. So here it is less than 11, so we will be checking left half. So we are passing low is again low is 1, mid minus 1 is 2 minus 1 1. So target again, so we get 1 1. So 1 is less than or equal to 1. So 1 plus 1 is 2, and mid is 1. So we check nums of mid, no, nums of 1 is equal to target, yes. So now we return mid index. So that's how we get here mid index. And if the mid index is not equal to -1, if the element is not able to search, for example, if we are searching 1, then we get here false. So it will not go inside false. So it will um, it will check the target is less than uh, if we had a target as 1, then 1 will be less than 1 will be less than a target, so it will go inside this left condition, and it will make mid plus 1 and high, where this condition in next this condition becomes false, and we will be returning directly minus 1. So uh, so that's how, if it returns minus 1, will not be going inside this condition. So in this case it didn't return minus 1 because 7 it has found at index 1, so that is what it returned. So index we have 1, 1 is not equal to minus 1, so it will come here, and 1 plus 1 is like I plus 1, which is 0 plus 1 is 1, and 1 plus 1 is 2, so that is what it is returning, 1 and 2. So that's how it will be going to return our answer. So and in one of my anyone, I will try to make this how in like in detail, I will try to make a video how this binary search work. But this is what it is recursive binary search. As you can see, uh, it is recursively calling itself. So that is the reason the space complexity becomes a log n, because here, and that coming to time complexity, since we are iterating throughout the array, where we contains n elements, so the time complexity will be n log n, because n for the outer loop, and binary search take log n time, so that is the reason time complexity is n log n. So and the space complexity is just log n. So as you may assume, like we are not taking any we are not using any extra space, but how it will log n space, because here we are using binary search. Recursively it will, in a worst case, recursively it will call this array, and it will search this array, and recursively it will take for log n, it will call recursively log n times. So it will be so those many times, which is log n times, it will be storing internally in stack. So that's how it is taking log n time, log n space, and also log n time as well. So as you have seen here, if we avoid of doing using recursion, you can you we can use the binary search, but if we avoid using by recursion, and if we do it the same algorithm by iteration, then the time complexity remains same, and space complexity reduce from log n to uh, log n to 1. So that is what we are doing in our next method, which is method 2. So here I haven't written uh, this code will remain same. So just instead of binary search, here we have to call binary search iterative. So this is using iterative. As you can see here, the whole code is same. So if you observe the binary search and this binary search using iteration, so both codes are same, but the only difference is, instead of calling recursively, we are just using a while loop. So here what we have called is, if low is less than or equal to high, we have we have found mid, and if nums mid equal to target, then we return mid, or we again started binary search in left side if target is less than mid, if not, then we started right side. So that is what, so here we will not be calling recursively. Instead we have while loop, and then if it is the mid is equal to target, then we like here we are returning mid. If target is less than nums of mid, then we will be just updating high equal to mid minus 1, which is this. Here we have passed this, so we kept all the variables same. We just changed this high if the element is left side of the mid, target is left side of mid. So that's what here we are doing, high equal to mid minus 1, and we iteratively search left side. So if it is target is greater than nums, then we will be updating low to mid plus 1. So that is what we are doing here. So will be recursive iteratively searching right side of the mid. So and this is also takes the login time. So that is the reason whole program using iterative search also take n login time, and space takes only order of one, because we are just using here constant space. So this is our solution 2, and now we let's go to solution 3. So the solution 3 is this is very efficient method. So this is using two pointers method. So here the core idea is what we are doing is initially we take it two variables, low and high. We initialize this index with these two variables. Index this low start from 0, high start from end. So low start from 2, started from 2, high started from 15. So we iterate we start a while loop until low is less than high. So in iteration we increment to low and decrement high based on some conditions. So in while condition, initially what we do is we add both 2 plus 15 17. So we check if 17 is equal to target, no. 17 is greater than target, yes. So that is the reason we decrement high, because the addition became larger than the target. So we will be decrementing. So now we have our high is pointing to index value, index with value 11. So again low is less than high, because index 0 is less than index 1. And again 2 plus 11 equal to 2 plus 11 equal to 13. 13 is again not equal to 9. 13 is again greater than target. So again we decrement, and again low is less than high, and 2 plus 7 is 9. So 9 equal to 9. 9 equal to target, true. So we will be just returning low plus 1, which is 1, which is 1, and high plus 1, which is 3. High plus 1 is sorry, low plus 1, which is a low plus 1, which is 1 here, because this is index 0. 0 plus 1 is 1, index 1. So 1 plus 1 is 2. So that's how we are returning 1 and 2 here. If our target was for example 18, then what it would have, it would become was like, if let's assume our target was 18, and our low initially point to this, and high will point to 15, and 15 plus 2 is 17. So 17. So our, let's assume our target is 18. So 17 is equal to 18, no. 17 is greater than target, no. It will come here, low plus plus. So low comes here, and now 7 plus 15 becomes 22. 22 is equal to 7 18, no. 22 is greater than target, yes. So high minus minus, so it will come here. And now 11 minus 7 is 8. 11 minus 7 is 8, and with 11 minus 7 is 18, and which is equal to our target. So it returns low plus 1 and high plus 1. So that's how it will work. So as you can see here, we are iterating through array only once, because low is starting at index 0, and high is starting at index last index, and these two indexes are low and high are traveling. Low is traveling forward and high is traveling backward until this condition. So low becomes high. So this will not this high will not cross over low. So if it crossovers, then this while condition stops. So that is the reason it is iterating through this given array only once, at once in a given program. So that is the reason the time complexity is order of n, and the internal all this statement, as you can see, take just order of 1. So that is the reason this is order of n. So the space complexity is we are just using constant space, so that is the reason space complexity is order of 1. So this is very efficient method than the above two methods. So yeah, this is our three solution, and I'll share the link of this solution. So I have shared this solution, three solutions here in lead code. So I'll post this solution link in the description of this video. And yeah, thank you for watching.